you're an example to follow. Thank you.
Thank you very much. Thank you. Thank you very much.
Okay, so we move to next speaker, which is Gianni Preve from Fondazione Inphotec. He will discuss some critical challenges when packaging photonic integrated circuits.
Good morning. Thank you for inviting. I just putting here my chronometer so I know the time. Yes, this is. So basically, let's start. Basically, I'm working in Inphotec Foundation. I am responsible for the packaging lab. So today, honestly, I was, as you see, I'm trying here to be a little bit critical on the packaging part, in the sense that we still have in the photonic world, let's say, some packaging problems, in my opinion. And even if I will illustrate to you a little bit of where I belong, Inphotec Foundation, especially for the packaging part, I will concentrate more on the problems I saw personally from my perspective working there with industry and also European projects. So, okay, in my opinion, all is in my opinion and some example of why I say it, but of course it's very, it's from my perspective. So where lies the minor challenges? I think it's like right now it's still automation, 3-5 chips, arrays, integration. We saw something today. Multiple input-output, we still have to go in and out with the light from the device. Pluggable is a question mark in the sense that a lot of people would like to have some pluggable device so to be easier to interconnect to boards and so on. And of course, high RF, we are going on and on with the RF. So in my opinion, not everything is solved. And there is some explanation for it, also related to the market itself for silicon photonic. Even if, you know, a lot of people say it's about millions there, but I still think that it's not really so easy to exploit the full potentiality of photonic integrated circuits. We had a workshop 1 year ago, almost a little bit more, sorry, but essentially the idea was for us to organize a workshop saying, you know, is volume packaging and testing of integrated photonic a mirage? That was the idea with these witnesses from all over the world, asking them, you know, from machine, from different perspectives. I mean, it was like, you know, a way to say, is it for real, this volume, you know, production, high-level production? So the case was debated, but as you see, no conclusion at that time. Okay, it's 1 year ago. Honestly, I didn't see too much more in 1 year to say that now the problem is solved. So basically, there is not yet a complete standard, and then we will see something more on why we still have sometimes some bottleneck somewhere in all the packaging environment. Quick, where I work, because I will say to you something related to what I see during my work inside this lab. We are Inphotec, as was mentioned before, in Italy, in Tuscany, in Pisa, and okay. I mean, if you need more information about Inphotec, you can talk with me later on. We started in January 2015. We have a front end, so 6-inch CMOS compatible line for silicon photonics, silicon nitride. We don't have essentially everything, but in a limited environment, we can be of support. Especially for passive and for you know, silicon optical bench kind of substrates where you can put lenses, you can put you know, solder evaporation and so on and so forth. We have the packaging line. Okay, this is a little bit our platform. You see silicon, glass on silicon. We are also able to make the old style fashion glass on silicon. With different refractive index difference. Again, if you are interested, otherwise I lose time. And then we have the advanced chip packaging line. This packaging line is, we call it packaging line with the idea to say to not only to companies basically that they can come to us and they have a certain kind of competences up to a point that if they need hundreds of pieces done, depending on the complexity, we can develop and then realize these hundreds of pieces. That was possible because at the time, let's say around 2016, we had an agreement with ST Microelectronics. ST Microelectronics at that time was still, strong on silicon photonic field. You know that nowadays they are, let's say, in standby. Let's put it this way. And at that time, they needed us to make hundreds of parts to test their technology. So we realized that for them, around 1,200 packaged devices with their substrate, of course, their component, guided a little bit by them. And so we were able to set up this line that is now has a little bit more, but essentially that was the starting point. And that helped us to understand where is some limitation in the automation during the time, because these 1,200 were not done in 1 year, were done in around 3 years, so 400 by year, basically, average. Okay, so first of all, a quick reminder, we have gratings, we have edge coupling, we have adiabatic coupling that we worked on in Inphotec, based not only on our technology, but also, working with suppliers. They supply to us devices, they ask us to make some kind of packaging. We have a lot of experience on the grating because ST Microelectronics was making gratings. They had the big line, 12-inch line in Kroll. So basically, they were sending to us the device already cutted, already with the electronic integrated. We just needed to put inside the package and then to make the alignment of the 12-in output fiber array. That was the starting point on grating. And we found some complication in reducing time and automate it. We have also the edge coupling that nowadays is growing and growing. We have some solution for it, still with some problem in terms of automation. And then we had with ST some test with this kind of coupling, the last one, and I will say something about it, but not so much. So what do we have for make automatic alignment and p-tailing bench at Inphotec at least? So the idea was to have something that is not operator depending, to be able to realize a bench, robotics, vision assisted, some way to, let's say, load as more as possible automatically the parts, and then to have, have a process, but then to be able to just say, okay, start, and all the other parts are made automatically. So pick up the fiber array, align, pre-align, optimization, and so on and so far. Okay, this is more or less what happened during time. So, the operator manually takes out and unwraps the fiber array. So you already start to see that if the environmental, the other part of the world doesn't help you, automation is not really possible. I mean, if you receive something like this is normally what you receive. Even ST was sending us hundreds of these parts. No idea that one man has to open, unwrap, put in position manually. This is already minutes, And then you have to place, you see the hand out there, and then you see that everything has to be placed in the right position. Then you can really start, and this can be done more automatically. This is an idea. The load of the device takes around the load fiber array, not the device. The device is easy because you have a robot that can pick and place. But the load of the fiber array takes almost 22%, just rough idea, of the total time, almost like the active alignment. We try to reduce as more as possible, but this is more or less what happens. So it looks like the first lesson we can learn is that you have to receive something as it is obvious in a certain sense, but in photonics it's not so straightforward, to receive something that is ready to be, aligned actively. This is for the input and output, especially, that you need. So basically, you can do also this kind of stuff directly on the board. You can try to avoid the package itself. You can put on the board. Still, same problem. I mean, okay, you can have a bench that is ready to accept the board, that is ready to make whatever you need, but still, when you have the fiber array, you have to unwrap, put in position, pick up, and go on, and so on and so far. So this is, in my opinion, a sort of limitation. The community has to work so that it's easier to pick up things, or things arrive already prepared so that you can easily handle in a robotic kind of environment, whatever it is. Because this is 1 meter length of fiber. So we try something, people is moving, but that was the starting point. We started to think, why don't you try to reduce the length of the fiber in a certain sense? So we work with ST, this is all work we make with ST, also looking for potential pluggable solutions, so to have the possibility at a certain point to have a small amount of fiber. You see here that Senko is doing something around 30 millimeter minimum length, so that you can maybe in the future pick up this kind of stuff already arriving ordered in an array. So you can easily place in a mounting machine, can be a bench like you saw, but it can be anything more focused, and then pick it up, pre-align with the vision, and then go in position, apply the epoxy automatically, and so on and so far. This could be interesting also because you can then try to go to our pluggable solution like you see here in the top part. You see that we tried, that they are not working, by the way. But we try to go in this direction, try to have bended fiber, to have smaller thing that you can, basically with the idea to automate everything. So not only pluggable in a certain sense, so that you can plug and unplug the fiber coming from outside, but also to be easier to automate the alignment procedure and pick up parts in an easy way, reduce loading time and unloading time. Still, necessary active alignment, of course, also in these cases. Then, okay, other kind of experience when you have this kind of let me check the time here. Okay. Here is another approach. So the other one, the first one is the standard approach with a view at our some pluggable solution, so smaller amount of arrays, you know. Okay, that's one point. Let's say the fiber array alignment is quite easy, but not so well automated right now. If you want to go really below 10 minutes, go to our 5 minutes complete process. Then people is, and also us, worked on European projects. So this is all European ideas, concepts that has to be proved on the field for real, for high production. In this case, the idea was to try to use the glass like a way to, to write with femtosecond laser, and then to write on waveguide on the glass itself, and then to put the glass over the silicon photonics through the grating, coupled from the grating to the femtosecond vertical waveguide, then turning mirror, and then let's say the waveguide on the glass that has a better mold field to match with the fibers. That was the concept at the beginning of this TerraBoard project. Honestly, yeah, something worked, but essentially we have a little bit high losses. At the end, the best one of the best of the best of the best was around 3 dB loss. Still, you can imagine to put a fiber array on one side, and the time to write the femtosecond vertical is, it takes an hour at least. And it's not automated at all. Even if this were available easily, then it takes, still you don't have any real big advantage from the packaging perspective. But we started to think about the glass. What about using of the glass lens, mirrors, to simplify eventually the packaging? So basically, okay, this is a little bit about more in details. You see the mirror, metallization, the glass, and whatever. Just like a first step to say, okay, that was a European project. We arrived at certain results. Now the European project is basically closed. A lot of red in terms of building blocks that are necessary in terms of automation, complications. Maybe another project will start, but essentially that was the first step. That opened it toward the glass interposer. So now we are trying to work on something a little bit different. First of all, you don't need anymore the femtosecond writing. You can handle things with lenses that can collimate and then focus the beam. So we learned that these as building blocks that are still necessary, you still need micro mirrors. You still need some little parts that could be a little bit still maybe complicated, but recently I discussed it with some companies supplying this kind of micro optics that is getting better and better and better, and we can take advantage of it. The automation is okay. Now we need to go to our sort of more passive approach. The passive approach, anyway, it depends on how accurate you have to be, and so this has to be a little bit to be proved on the field, really, with this kind of parts. As you see, we still have in this approach that we try to develop we still need the fiber array to be aligned. Still, you need some active alignment. So the advantage is to have a lens and a mirroring, even if you have advanced micro optics, is not so straightforward to the packaging, because you still need active alignment, picking up parts and so on. So we thought that the best would be, instead to have the necessity to have always the fiber array, and still thinking that the pluggable solution could be interesting for the market, we thought that something like you see here. The basic concept is that what if we can really try to find a way to passively mount at wafer level the micro optics, okay, passively, so taking advantages of the machines that are improving in terms of quickness and precision, and still have the possibility to have on the packaging side. You see here on the right side, this is just of course it's a picture created ad hoc, but basically where you have let's say a female of an MT connector. To do it, you need the collimated beams. So we started to think that maybe a good idea for trying to improve this automation, first the technology and then the automation friendly, was to try to collimate the beam. So if you have a collimated beam, we can reduce tolerances, and if you reduce tolerances, then you can have maybe more classical machine to align things one respect to the other, because you have, better tolerance in this sense. So essentially, we started with this concept, the microcollimator, just quickly. That was also written by femtosecond. That was also partially working, but it's too expensive, too long time. Temperatures, from the temperature point of view, was not really reliable at all. What a tentative. The tentative was not successful in general for our final purpose, but let's say the idea to have something collimated coming out from the grating, still we are in the grating scenario, it's maybe feasible. Now we are working on this kind of stuff, so I have no real result. I'm just ideas of what can be helpful. So to be able to have a lens that collimates the beam, and then you have this, you can have a prism out there. You don't need to do a bulky optical part. So probably I saw people in the micro-optics field can do very amazing things nowadays. So probably this kind of stuff could be possible. And you can imagine that when you take out from your wafer, because you can try to mount at wafer level this kind of stuff, then you have a collimated beam coming out, and then this stuff can go inside some markers on the package or on the board and see if we have a collimated beams that can fit eventually with the connector guys. That brings us to another story, the story of, I mean, the entire photonic people has to work on the solution, not just the packaging and just the front end, for example, in this case, a company like US Connect, that they are making connectors, they are already counting on this kind of collimated approach. Exactly to do a pluggable connector that make a pluggable solution, relying basically on a sort of interposer that collimates the beam to reduce the tolerances. This is how I understood it talking with them. And they are improving. The problem is not conceptual, it looks like in the connector field, but it's more for, you know, reliability, to really be able to make in numbers, volumes of this kind of approach. So it looks like that for grating, I think that we don't have yet, from what I see in Pisa, in Tuscany, traveling a little bit, but there is not yet a complete solution that is so automated friendly, because either we have the fiber array on one side, then we are stuck with all this unwrapping, trying to reduce steel there for making volumes, not making 100 a week, real volumes. And or we have to go to our, I think, sort of glass interposer that can help in reducing the tolerances, and so that can bring us first to mounting them at wafer level, reducing cost and maybe speeding up. And then secondly, simplifying subsequent alignment at the package level or whatever level you want. Okay, so not to lose too much time, this was just a research made with ST for adiabatic stuff, so I don't think I have enough time to talk with it, but in any case, when you are really dealing, in our case, from the packaging perspective, I had to deal with this kind of team photonics glass with the waveguide, you know, coming from the top to the bottom, and then to be glued to a quite long, not long, few millimeter long coupling region with the silicon photonic realized by ST. So it was a strict contact. We needed to stay at not more than 1.5 micron of thickness of epoxy with this kind of device. Here you see the results. They were really happy. ST was happy, because they were able to get really below 1 dB losses here. But honestly, from the packaging, okay, this was just a research part, but from the packaging point of view, the big complication was the parallelism, and to guarantee along the coupling line that you have 1.5 maximum of epoxy. So, okay, it's feasible, but if you have to make volume, and also still you have, you see, the 1 meter stuff, you have the interposer from Team Photonics attached to the cost of this part is very high, so it's not so cheap. So basically it looks like that for some niche it could be, but in terms of volume, high automation level, it's a little bit tricky in my opinion. Anyway, of course, it's my personal opinion. We have other people doing in different way. IBM was doing in the past, years ago, this kind of approach. Maybe they do now successfully. Of course, I have not access to industry that makes packaging. Maybe they have a beautiful solution that I don't know. You have Optoscribe here that is working on this kind, again, of approach, so that they can, let's say, use an interposer to have this kind of. They also use mirrors, and so I think that the glass as a medium for interposer and simplify things is still valid. The point is to try to understand which is the best for the future volume automation programs. I have no answer. Okay, then we have the edge approach. You know, it's improving. A lot of foundries are improving their spot size converters. The spot size converters are going from, at the beginning they were like 3 micron square mode field diameter. Now they are improving. I am in contact with a company that, IHP in Germany, that are going towards 6 microns. So the people is trying to move toward more friendly parts, but in our case we essentially are still counting on the mode, an interposer that is mode converter. So let's say we start from 3 microns or 6 microns or whatever is necessary, and we go out to the external world. Here you see it's a good way that I'm showing him here to use this interposer not only for the edge adaptation and so to be able to align with relatively low losses the fiber array to the output, but also can be useful for 3.5 integration. Now, I don't want to talk about 3.5 integration at all because you had all the morning. I just say that in Inphotec we just buy the laser, we put on a substrate, and then we have a collimating lens, focusing length, an insulator. This is what was asked by us from this project that we are doing with the space agency. So they want an insulator in the middle, and it's a specific niche probably, and so we prefer for now to stay on the edge coupling as it is with lenses. All can be done with the bench automatically. Basically, it takes a little bit of time in any case, because to make the alignment respect to a 3 microns mode field diameter on the silicon photonic side, collimate the beam, find the light to monitor on the chip. It's a little bit long. It takes around, instead of the 10 to 12 minutes of the fiber array, it takes around half an hour, more or less, right now. Again, with epoxy and so on. So maybe for space application can be good because, you know, the extra they put in terms of development and cost of the single chip is more. They need hermeticity also and so on and so far. So maybe this could be an interesting approach. Of course, I'm aware that a lot of people is working on other approaches for 3.5 integration we saw. And in my opinion, we are still a little bit behind on some solution in terms of volume. But anyway, it's my personal opinion. This is what is an example of what I show with you. And I think that I see now Pasquale there, you know, 25, 30 minutes to mount all this kind of stuff. It's quite reliable. We made some cycle, we made some shock, you know, for space application, you need to make some reliability. But, you know, more than this, I don't know, we cannot do, to go really down in time. It's very, very complex. This is already was shown. So my personal tentative conclusions is, okay, also we have the testing here that is not so, it's not covered, but I think that automated, the volume packaging and testing is still a little bit far, or let's say moving to our reality, but slowly, maybe because of the market itself. No standards. I know that there is the SC, the IEC started the work recently, a few years ago, with this SC86C. I participate. Is a work group of 4. They are working toward a certain way to put some standards, how things has to look like. They are already in an advanced phase, but I'm not aware that it's fixed. Edge coupling is more and more important. Maybe we can use lenses also there in some clever way to collimate the beam and simplify subsequent alignment. And then multidisciplinary efforts are very mandatory. We need, you know, not only proper front end, but also we need the vision system, high precision positioner, then the software, the human-machine interface, how the fiber will arrive, how the connector guys will supply. So essentially, all the part has to, let's say, agree on a certain way that helps packaging people like me to be more effective in terms of future automated processes and eventually volumes. Okay, collimated I already saw, pluggable solution not yet available, but are improving little by little, and that's it. Thank you.
Thank you, Gianni, for your talk. Now time for questions.
Thanks, Gianni. I see a little bit of negativity in your speech regarding. So it looks in your view that every player is playing its own game, and none of them are collaborating. That's what I see from you. But I would like to ask you another question. Yesterday in the afternoon, somebody was mentioning that the test of these chips should be made by the assembly or packaging houses. And I see you post there a lot of timings for the assembly. And do you perform any other tests? Because you only mentioned the visual inspection of the grating couplers. Do you do this in your packaging line, or you plan to do this in volumes as well?
We do not do with the same bench. We have another in the university. There is another lab that has a probe station with alignment, a little bit less complicated, but able to do this kind of testing. Aside, I agree with the person that yesterday was saying that maybe to just start a new company just doing testing. I think that was the claiming yesterday. I agree with him. I think that who does the packaging at a certain point to be a company that is growing strong and give full service can do part of it as well. Maybe not all, maybe depending on the customer, but I think it would be good to offer as a company packaging services plus some testing, some kind of testing. In terms of, I don't know if I can comment, but in terms of collaboration between parts, I'm not saying that everyone, maybe in the past was more. We are improving, because if the market will request volume, we must have all this kind of agreement. One of my major problems was the connector people. If the connector people does one thing and I'm doing something that looks like, but it doesn't fit really well, that nothing is reproducible at the right rate and in the right way. That was something that I think the market growing and the technology growing, and people that makes technology is not just me, like a packaging guy, is all together trying to find the best way. And yeah, my experience is that some years ago was not exactly like this. We are improving, of course, but still some, in my opinion.
Okay, I think that we got a clear idea. Need more cooperation. Okay. Thank you, Gianni, for your talk.